Hello, my name is Chris Bowie, and my Capstone 2 project was forecasting EMS call rates in San Francisco. So the problem I was trying to solve was how should EMS vehicles be allocated throughout San Francisco on a daily basis to reduce response rates by having them correctly distributed towards the areas that will have the highest call rates. And so the use case of this is that by predicting EMS call rates by neighborhood in San Francisco, we can use that information to prepare and distribute the EMS service vehicles in the areas that will be most affected. The data that I had was 5.32 million EMS calls. I started out by removing duplicates to have just the single calls given one vehicle response. And I decided to do my EDA on the full scope of data, which was 20 years from 2000 to current day. And to have the predictions work on a daily basis, I aggregated my data into 3-hour time periods from 0 to 3 o'clock, from 3 to 6, and so on. And to test the models I ended up running, I did my predictions on a week in August in 2018. So I distributed my data by neighborhood, and the EDA for the seasonality that I discovered for the years, you can see as follows of pretty much across the board, each neighborhood has been increasing the EMS call rates over the last 20 years. The monthly seasonality is also pretty consistent for every neighborhood, where it dips down to the least around February and the highest around the holiday season. The weekly seasonality seems to similarly peak around Friday and hit a minimum around Sunday. And the daily seasonality, which is the most important for the predictions, is also kind of intuitive, where it seems across all the neighborhoods to peak around early afternoon and to hit a minimum in the early morning or late night. And the neighborhoods, you can see here that have the neighborhoods are in order of greatest call volume to least in the legend there. So you can see the Tenderloin, which has the highest call volume, has the biggest swing of seasonality, and that tends to be the trend. So the two models that I compared were an ARIMA model and Facebook Profits model for time series forecasting. For the seasonal ARIMA model, it had a very high runtime, and so I decided to limit it to only using 3 previous weeks of data to predict a 4th week, which would not do well for forecasting out a long period of data to capture a yearly seasonality. But in terms of a week, I figured that should be able to capture generally the call volume in the given month pretty well. So on that, I ran a grid search to optimize the hyperparameters, ended up with the ones you can see there. The 8 is for the 8 different 3-hour segments during the day, at a total for 24 hours. And the graph you can see covers 2 weeks, where the first week there is data that the model was trained on. So that's the 3rd week of the 3 weeks it was trained on. And the second half is the 4th week that was predicted. You can see the actual versus the predicted values. And the Facebook Profit model, I was able to it had a very quick runtime, and so I used a full 2-year scope of data to predict the target week, and the graph has the same dates are projected there. You can see they both do a pretty good job of capturing the daily seasonality. So here are the RSME values from the 2 models, and I compared them against, as a baseline, just using the previous week as the prediction of the following week. So these were all based on that same week in August. And the RSME was able to drop a fair amount using the ARIMA, which the name there is for a seasonal ARIMA, is what Ceramax is, and the profit model. The profit model performed slightly better on the test data than Ceramax. So I decided to proceed forward with the profit model to compare the different neighborhoods. You can see here by neighborhood daily 3-hour increments. So these are the top 3 busiest neighborhoods in terms of call volume. And you can see they're relatively similar in terms of the daily seasonality that we're seeing, but it captures the peaks a little better. There's some variation that we're seeing it capture within the different neighborhoods. Similarly, the weekly by day, which this again is trained on 2 years of data. So the predicted yellow line there shows the general projected daily call rates for each neighborhood. And so my next steps would be using an LSTM model, because then I could capture more features of the data in terms of the call types and the kind of proportions of call types happening in any 3-hour window, as well as I would, in the profit model and the ARIMA model, I could add holiday features in, and that would allow me to capture some of the more specific trends on a yearly basis, as would be self-evident, of capturing certain holidays, because those would generally correlate to peaks. And I would also optimize the parameters in profit, because this was run on the default parameters in that model. And I would also test it on more weeks throughout the year, because this was run during 1 week and a week when there was no special events going on. So there would be a lot of situations in specifically where I think the ARIMA would not perform as well as profit in that prediction. And for further use, I think there'd be a lot more to explore in the models in terms of developing out better feature importances, if those could be included in the profit model. You can see here in the 2-hour period that the profit model was trained on, there was a peak in September 1st. And so I investigated that, and that was a day that there were all-time record high temperatures, as well as then a peak in April, on April 21st, where I looked that up and there was a power outage on that date. So by graphing and finding the high residuals of the predicted and actual, I'd be able to find certain parameters that could be a better prediction. Like for this, we know that really high temperatures are going to lead to an increase in EMS call rates as well as power outages, and that would help better prepare the EMS infrastructure for handling increased call loads. Thank you.